Okay, this is lesson 9. Who has the first question of the warm-up vocabulary review? Why is 1 3/8 called a mixed number? Nathan in the back.
Because it is a whole number and a fraction.
Nice. There we go. It consists of a whole number and a fraction. Any questions about that? That was a pretty easy one. Okay. Who can walk us through number 2? Number 2. Let's just go up and down the rows again. Adepoju, go ahead.
So we have to convert 2/3 because the LCD is 12.
Right, so the LCM of 3 and 12 is 12. So the LCD is 12. And so we need to rewrite our first fraction. What's it going to become?
8/12.
So in order for us to get 12 in the denominator, we're multiplying by a factor of 4. And then we get 8/12 plus 5/12. Any questions up to that point? Are we good? Okay, so continue.
And the answer would be 13/12, which is an improper fraction.
Very good. So the final answer is 13/12. We have an improper fraction. And how we got to that is we add the numerators, kept the denominator. Okay, are we good? Now, Adepoju is correct. We have an improper fraction. So how do we fix our improper fraction?
We have to convert it to a mixed number.
Right.
It would be 1/12.
We're going to convert this to a mixed number. And 12 goes into 13 one time, but we have a remainder of what left over? 1. So that is my numerator, 1 and 1/12. Okay? Adele, you want this next one? Go ahead. Walk us through it. Do I need to change anything?
No.
Okay, so go ahead.
So C minus 5 is 10.
Right, so then what do we get when we take that away? 10/16. We keep the denominator. Are we there yet? This is where many of you are stopping here. You're just shy of having the full correct answer.
No.
And this is one of our choices on a multiple choice, and you guys are picking this choice. I don't want you to pick this choice. We want to get all the way to the correct answer. What's the correct answer? Is there a factor that will divide into 10 and 16? What is that? 2, right. So let's go and do that. Now remember, we can't just do it to the numerator and then forget about the denominator. We got to do it to both. So go ahead and do that. What do we end up with? We're not multiplying by 2, we're dividing by 2. Right.
5. 8.
Nice. It's here somewhere. It was there, I promise. I don't know where it is. All right, so this is the first time I've done it. I apologize. Do you guys like it better this way?
No.
All right, you guys would rather I write it up?
Yes.
It's hidden from me, so I... Here it is. There we go. All right, I'm not sure why things got shuffled around, but there we go. Okay, who's got the next one? Shh. Let's go up the road, Taylor, and then once you're done, you could go to the restroom. Walk me through this. Shh. I don't know why I hear the singing or the talking to yourself. Please stop. Go ahead.
So we have to take both mixed numbers and convert them to improper.
Okay, that's one method. Go ahead and convert your mixed numbers. What do we get?
So 5 becomes 11/2.
Uh-huh.
And 6 and 3/4 becomes 27/4.
There's still a number of you guys that don't know how to go from a mixed number to an improper fraction, so I'm walking you through it. 2 times 5 plus 1. That's the numerator. Got it? Do you see that first mixed number? That's what we're doing mentally. The denominator times the whole number plus the numerator. And then, what did you say you got for that fraction, Taylor?
For the first one,
11. And what did you get for the second one?
27/4.
27 over 4, and then they don't have the same denominator, do they? Right, so how do we fix that?
We have to find the least common factor.
The least common multiple, LCD, or LCM, and then once we get the LCM, what is it? LCM is going to be 4, but we're going to use the factor 2 to rewrite it, okay? So we're going to get an LCD of 4, so what do we end up with for 11 halves?
So that's 22.
Right? And then what do we get now?
And since we're adding, it's 49
Okay,
which is 12 and 1/4.
nice. Are we good? That is a long way to do it. I'm going to go over, and you guys remember I said there's obviously more than one way to do the problem. We're going to talk about the other way because it's a little bit faster, okay? For some of you, just understanding this was tough, and so you're getting good at this. And so if I'm showing you another method and you're comfortable with this method, I want you to understand the new method, but I ultimately want you to get the right answer, okay? Eventually, we should understand more than one method. A day? How we got this one? What step did I lose you on? Okay, so the first thing is we take our improper fractions, our mixed numbers, and rewrote them as improper fractions. Okay? So do you see that we have this, and that's what we're thinking mentally, 2 times 5 plus 1, 2 times 5, that's the numerator. And we kept the denominator, right? And then this one over here, you see what we got? 4 times 6 plus 3, 4 times 6 plus 3.
So you always keep the numerator?
Yes, when you're going from a mixed number to an improper fraction, yes.
So over there, why is it 11 times 2?
Because 2 times 5 is what? Plus the 1. And then, like you said, we keep the denominator. Okay? And then that plus. And then this number, 4 times 6. What's 4 times 6? Right, plus the 3, 27. And then we keep the denominator. So are we good now to this step? Okay. And then now we're going back to what we learned at the first part of this unit. We can't add or subtract fractions unless we have what? Do you guys remember? Like denominators. So I've been telling you recently, because we were doing multiply and divide, those are the easy ones, right? The harder ones to me, and it seems to be more difficult, is adding and subtracting fractions. Because you can't just add them straight up. You have to check to see that your decimals are the same. And if they're not, we have to fix it. We have to make the adjustment, right? So that's what we did here. The least common multiple of 2 and 4, if we skip count by 2 and we skip count by 4, 2, 4, 6, 8. And if we skip count by 4, 4, 8, well, 4 is the least common multiple. So that's our LCD. So we need to make this have a 4 in the bottom, right? So to make it have a 4 in the bottom, we got to multiply the numerator and denominator by what? 2. So 2 times 2, 4. And I can't just do that to the bottom. I got to do it to the top. 11 times 2, 22. Okay, so are you good with me here?
Yes.
Okay, and now this is easy because now we have a like denominator, right? So we just add our numerators. Boom. Here's what we get. Okay, we're keeping our denominator the whole way. Okay, now what kind of fraction is this today? Improper fraction. And then remember how to do that. You can do the long division. Do you want me to walk you through it? Okay, so if you're on top, are you in the house or out of the house? In the house. So I got 49 and then 4, right? How many times does 44 go into 49? Or 4 go into 4? 4 goes in 4 how many times?
12.
Well, you can say 12, but let's just break it down because sometimes we're not that. 4 goes in 4 one times that's 4. Subtract that. Bring down my 9. How many times 4 go into 9? 2 times, because 2 times 4 is 8. And then we subtract that, and then we have this remainder 1, right? So quiet, please. So I have this remainder 1. I have this quotient 12. And then I have this number right here, 4, what we're dividing by. So do you see where the pieces go? Okay, are we good? All right, so I can move to the next problem now, right?
Yep.
Okay, so I want to continue with this problem because remember we can't always add or subtract, so we have to make some adjustments. We have to make some adjustments if we're multiplying, if we're dividing, and if we're adding, subtracting. We have to make an adjustment here, right? So I think I'm moving up the rows and kind of, Moyen, can you help me out with this one? Right, so let's make the whole number into a fraction. It's going to be an improper fraction. What's it going to be?
8/1.
Right, and then what else?
And then we make the mixed number also into a proper fraction.
Okay, so here's what we're going to do. Right? You guys understand what you said? I'm going to take the whole number, make it to a fraction. Now I got to make the mixed number an improper fraction, and this is just like what we did earlier. Okay? Now, what was the result of that? What did this become? My improper fraction from that mixed number.
12/8.
Well, hold on. Multiply, add, right? So let's fix that.
That'll be 15.
15 with what in the denominator? 15/4, right? And then if I have 15/4, I can't take that away from 8/1, can I? So I have to fix that. I need the LCM of 1 and 4. What's that going to be? 4, right? And so how do I rewrite 8/1 into an equivalent fraction where 4 is in the denominator now? Do you remember what I do to make it so we can work with it? Right, what am I going to multiply by?
4.
Right, and am I just going to do that to the numerator or the denominator? I have to do to both, right. So here we are. So what does that become? And I see some hands up for questions. Questions? Go ahead. Okay, what's this going to become? 24/4.
32.
Okay. And I'll let you guys have multiplication charts when it comes to the quiz and the tests. So some of you guys are tripping up on that. The goal is to not need it, but I'll let you guys have it. By the end of the year, hopefully you won't need it. Yeah. That's fine. So now, what do we do?
We subtract 32 from 15.
Right. And what do we call 32 and 15? They're what of the fraction? We're subtracting the numerators, correct. Okay, so what's my answer going to be? Or we're closer to my answer. What's it going to be?
17.
17 fourths. And are we done?
We have to send it into a mixed number.
Right. What's that mixed number going to be?
4 and 1/4.
Nice. Okay, are we good? Okay, I have some questions. Yes.
I got the same answer, but I did it a different way. So, like, could I, instead of writing 8/1, could I write it as a mixed number with an improper fraction?
Yes. So the method you're talking about, I wasn't ready to show because I felt like I was going to confuse some people, but I'm going to show that today in my example. And so I'm going to come back to what you're talking about, okay, and hopefully make the connection. So I might invite you to actually explain your method a little later in the lesson, okay? So Jason,
I did 8 minus 3, got 5, then 5 minus 3/4, and got 5.
where are we at? Where are we at? 8 minus 3?
8 minus 3, asked the question, got 5, then 5 minus 3/4.
Point to me where you're talking about because I'm not sure I understand where your question is.
8 minus 3, 5, 5 minus 3/4, 4 and 1/4.
So 3/4, right? So your question is 8 minus 3 is 5.
Yeah.
But then you got to take away 3/4 more.
Yeah.
Okay, so have a seat, and I'm going to explain to you what you're talking about. This kind of goes back to what JLo's asking. So 5, I can think of 5 this way. Can I say 5 is really, and I'm going to choose this intentionally. What's 4/4? 1. So what's 4 and 4/4? 5, right? So if I replace 5 with 4 and 4/4, okay, what's that going to be? Right, then you just answer your question now, right? 4 and 1/4. You said, how did I get 4 1/4? Do you see how we got it?
No, I said that I did it.
Oh, you did it that way, and that's what you got. And that's the way you're talking about, right? We're going to be using this method today because I'm going to start showing you guys different methods just because I want you guys to be versatile in your problem solving. So let's go ahead and move on to the lesson. Can I get somebody to read through what you'll learn, why learn this, and we're going to talk about this. Leah, I'm sorry. Laura, do you mind reading?
To change units of length, capacity, and weight in the customary system. Why learn this? Most people in the United States use the customary system of measurements for length, capacity, and weight. Changing units allow you to compare measures and compute them as carpenters do.
Okay, so customary units of measure. Here are the categories. They represent length, capacity, and weight. Can somebody give me an example of a device you would use to measure length? Trinity. A ruler. Another example? What's that? A yardstick? How about a tape measure? Okay. Have you guys used any of those things? You should have. Okay. What about capacity? Capacity represents like space. How much is it taking up? Have you guys used anything to measure capacity? Yes, Nicholas. A measuring cup, right? Okay. Anybody have another example? Trinity? Oh, yes, a graduated cylinder. Nice. I was not expecting that. That's a good one. So when you guys take a science class like chemistry or sometimes even biology, you might do some experiments, and they'll have a cylinder, and marked on the cylinder are different levels, and that measures volume, capacity. Nice. Good job. Okay, and what about weight? What are some examples of things you would use to measure weight? Nathan in the back, yes. A scale. What kind of scale? There's a couple different kinds of scales. Like a scale for what? A scale in your bathroom to measure your weight. Does anybody got another example? You guys go to the grocery store with your folks, right? Don't you guys? Ade, go ahead. Nice, nice. Sometimes if you go to, I know I've been to a market before where they had a balancing scale, and that's what they used to measure the weight. Okay. Does anybody have another example? Yes. Yes, that has the basket. Okay, so that's good. Nice. So I have some pictures here. This is a digital scale. If you take a high school chemistry class, you might see one of those. And then some of you guys made the suggestion of a measuring cup. Now, here's the problem, and I'm going to walk around to see what you guys do with this. And I'm even leaving up the information that we have right here. So in the chart, we see the different customary units of length, inch, foot, yard, miles, and they're increasing. These are the smaller units. And then how many inches are in a foot? 12. And then how many feet are there in a yard? 3. And then we have a mile, and they increase. And here are the equivalent relationships that you just gave to me, right? And then here are some for capacity. There's one I want to point out to you because this is what students have been messing up on all day. They confuse fluid ounce with ounce. They're not the same. Fluid ounce is talking about space, how much we're taking up, okay? Capacity. All right, and the relationship between a fluid ounce and a cup is 8 fluid ounce equal 1 cup, okay? I'm going to give you a big hint. When you take the test on Wednesday, one of your workpad questions is going to require you guys to be able to convert these, okay? And it's going to be a big one, and you're going to need to label it. So now you guys are going to look back at the last quiz where some of you guys got 2 instead of 3 points because you didn't label it. And you're not going to make that mistake on the test, right? You're going to need to label it because that question, I think, is worth 6 points. So don't mess up on that. And then weight in pounds, okay? A pound is worth 16 ounces. Don't confuse that with what? Okay. How many fluid ounces equal a cup? Okay. All right. Can we answer this question? And I'm even leaving up the equivalence that relates to that. Can I get somebody to read this? Quinn, go ahead.
A carpenter has a board of 10 foot long. He cuts a piece 5 feet and 3 inches long from the board. What is the length and feet of the remaining pieces?
Okay. What I need you to do is I need you to try this problem. And we're going to discuss it here in a moment. And throughout the day, I've seen some different strategies. And so my method might be a little different than yours, and you might get the same answer. But I think at this point, what I really need to see you do is what? What? I heard it. What should you do right now? What do I always say you have to do? What?
Try.
Try. I need you to try. You don't know the answer. I need you to try. I'm getting kind of tired of repeating that. You guys know now. I need you to try. Did you go? Thanks. Okay. After Ed, would you please? number of you have started, and some of you are sitting there with the blank sheet, and I'm wondering if it looks to me like you're thinking, but you're maybe hung up. So can I give you guys the first hint? Quinn, can you give us like the first step you would take?
Well, the first step I did, so I realized that it was in 3 inches. But then I realized that I cannot do that, so I had to take away 1 from the 10 and convert it into inches, and then
Okay, you're on the right track when you looked at the inches because we're talking about what here with the 10? Feet. And then, so here we have 5 feet, 3 inches, right? So you're on the right track. And so you said you took away something.
I took away 1 from the 10.
Yeah.
9.
Okay, so you're on the right track. And some of you guys might not be using his strategy. This is a strategy that's a little different. Lola.
Well, what I did, so first I took away 5 from 10.
Okay,
So, like, we just got that out of the way.
right.
And since there's, can I give the answer?
Well, just walk me through your steps.
So, I subtracted 5 from 10, so I had 5.
Uh-huh.
And now, since there's 12 feet, no, 12 inches in a foot,
Uh-huh.
I had to subtract 3 from 12 and 3 from 10, which I did at first, then I realized my mistake.
Uh-huh.
So 12 minus 3 is 9.
So here's what's happening with your strategy, and you have to be careful because you're switching units halfway through your problems, okay? So here's what I would prefer you do, because if you're not careful, that can go wrong, okay? So watch this. The first thing is convert 5 foot 3 inches to 1 unit. Well, 5 foot 3 inches, that's what I was trying to piggyback off what Quinn said. How many inches in a foot?
12.
Right. So what part of a foot do we have when we say 3 inches? 3/12. And then it simplifies to 1/12. You don't have to simplify in this step, but it's to your advantage to do that. Okay, so now what we're doing next, how are we going to solve this problem now? What's the next step? Jayla. Okay, nice. So we're going to take away 5 1/4 from 10. And what you're talking about, you're going to make 10 into, go ahead, say it.
I was gonna make 10 into 9 and 12.
Okay, so that's because you didn't simplify this, right? If you'd have simplified it, you would put 4/4, right? But you didn't, so you did minus 12/12. And so here's what Jayla's talking about. Okay, do you see that? So if I kept this 5 3/12, I would choose a fraction equal to 1 that would be compatible with my 3/12. But that's not what I had. I simplified, I got 1/4. You guys understand? So we're being strategic here about this 9, because what's 9 and 4/4 really? 10. It's really 10, right? Because that's 9 plus 1 whole is 10. Now I could have said 6/6. Isn't 6/6 a whole? Right? But that wouldn't have been very useful to us because we didn't have like denominators, right? So we want to pick a whole, a fraction that equals a whole, that is going to help us out. Okay? So we're on the same thing. Now, what did you end up with?
I ended up with 4 9/12.
4 9/12. So here's, we'll walk through this. So if you take a look, I can take my whole numbers. What's 9 minus 5? 4. And then these are like denominators, so 4 minus 1? 3/4. Are we good?
No.
Where did I lose you at? Okay, Adipoji, you were out for a while, so let's go backtrack. So we're trying to solve this problem, right? We're trying to saw off this 10-foot piece of wood, 5 foot 3 inches. Well, we need to make this all feet. So we're going to use a mixed number. 5 3/12 of a foot. Isn't 3/12, right, a fraction of a foot? That's what 3 inches is? Okay, the 3/12 of a foot. Okay, are we good? Is that where I lost you? Okay, but now once you understand that, you're just going to subtract from the 10 feet the 5 1/4, which is that. Are we good? Okay. All right, so who else has some questions? Okay, yes.
The part where it says 9 subtracted by 5 plus, does the plus mean you actually add it, or is just like meaning?
Well, that's a good question. Do you guys remember when you have double signs, what happens? So this ends up being a negative fraction, so it'd be a plus negative 3/4. Do you guys remember what happens? Do you guys remember? So now I'm trying to connect what we did before. So this would really be a what? Minus, okay? So a lot of the pieces are starting to come together now. So that's a good question. You see that you have a plus, and then this is a negative fraction, but it's really just minus that fraction, right? So it'd be a negative, right? So we're subtracting that away.
9 minus 5, which is the whole number, and then there's...
But here we didn't get a negative, right? This was a positive. So in this case, this wasn't even a negative fraction. 4 minus 1 is what? 3. So that fraction is a positive force. But if it had been a negative, then you'd have to turn it to a negative. Okay, so a lot of that, hey, we got two signs. That's what you're thinking of. But this was a positive 3 in the top, right? 4 minus 1 is a positive 3. So it's a positive fraction. So plus a positive fraction. Okay? All right, yes, question. Go ahead. Who's out right now? Let me see the list. This is your next problem. Go ahead and try to do this problem on your own. I'm going to walk around if you need some help. We converted it feet, so it's done. But you could change that into inches if you want, but that's going to be 1 3/4. But left over. Okay.
So what if you went from before it said, over 5 feet 3 inches?
Right? So if you wanted to say this was inches, what's 3/4 of a feet in inches? How many inches would that be if I wanted to figure out inches? Well, make that into a fraction where the 12 is the denominator. What's the numerator going to be? So you could write this. That's a good question, Jayla. I could say 4 and 9 inches, 4 feet and 9 inches. I like that you're thinking along those lines. That's good. Okay. Did you guys understand her question? Okay. Go ahead, Olu.
So if we do, like if we were on the quiz, or we did 4, 9 over 12, would it still count, or do we have to simplify?
You know they're going to give you the answers in a multiple choice. You need to pick the best answer. So if it's asking you specifically for that result, they might give that as an answer, but that's where a lot of you are messing up, is you're not giving it in simplest form. But here we had to go backwards because she wanted to know, hey, can I say 4 foot and then what this is in inches? And that's what we did to go backwards to it. I mean, and we're going to talk about that a little more in a little bit. Tori.
Okay, so I'm going to see if my method was guaranteed.
Uh-huh.
So what I did was,
Are we on this problem right here? Which one are we on?
I'm trying to finish number 2 right
Okay,
now,
go ahead.
but I'm doing number 1.
Okay, so we're doing this one. Okay, so what's your question?
So what I did was I turned 10 feet into 120 inches, then I turned 5 feet into inches, 63 inches, I subtracted, and I got 57 inches.
Okay, I see what you did. So you rewrote these as improper fractions? Is that what you did?
No.
Okay, so walk me back. Where are we at? Are we on this? So you took 10 feet and you made that into inches, right? And so how many inches is that? 120 inches. And then you're going to subtract how many inches is in 5 feet? 63 plus the 3 feet?
Plus the 3.
Or the 3 inches, sorry. So,
No, it's 60 plus the 3.
okay, so 63 inches total, right? And then what do we get? 57 inches. But now we have to convert that. They want to know, did they say in feet? The length in feet. Now you got to rewrite that in feet. How many feet is that?
That's
4 and 9/12. And we simplify that, and what do we get?
4 and 3/4.
The same thing, yes. There's more than one method, and I don't want to dwell too much on all the methods, so if you have additional questions after we go through this next problem, we'll get back to that. Can I get somebody to share with me their answer for this? Lola in the back.
Okay, so first so there's 10 feet, so there's 10 minus 8 and 5/12, this is a mixed number.
Okay. And then, good, 8 and 5/12, good.
10 is equal to 9 and 12/12.
Nice.
So now we have like denominators, so
Okay, and so, right, the whole numbers, we're going to subtract that. We do get 1. What about the fractions?
The fractions, you get 7. So the answer is 1.
Okay.
7. Well, you get 7, but since it's 12, it would be 1 and 3. Wait, yeah, 1 and
No.
1 and 7, 12.
Yeah, there we go. Okay. This one was a little easier than the first one. Did you guys understand this one a little bit easier? There was a couple less steps in this one as opposed to the first example. Okay, questions? Yes. For what? So if you had 10 minus 8, is that going to leave me with 1 foot? 10 minus 8 is what? 2, right? And then I have 2 take away 5/12, right? Is 5/12 equal to 1? So think about that. So conceptually, if we estimate, using our strategies for estimate, that's not even going to be close to 1. Do you understand? It's not equal to 1. Did you use this method? What was the method you used? Okay. An improper fraction?
Yeah.
Okay, but then you have to get like denominators.
I did, and I changed the 10 over 1 into 50 over 5.
8 times 12, what is that? That's 90, that's 80 plus 16, that's 96. 96 plus 5 is 101, right? Over 12. And then this becomes over here, what's this going to become? This is going to become what? 120 over 12. Well, what's 120 over 12 minus 101? 19 twelfths. And then what's 19 twelfths? That's going to be 1 and what? 1 and 7 twelfths. Same answer. So some of your math is off, but I need to move along because we have some other problems. We're going to have to get through this, or we're not going to finish any of these examples. So take a look at this. We're changing from a smaller unit to a larger unit, you divide. To change from a larger unit to a smaller unit, you multiply. So Jonah has 30 fluid ounces of juice, and he wants to pour this juice into and fill as many 1.5 cup servings as he can. How many servings does he get? Well, first of all, this is that problem. How many fluid ounces are in a cup?
8.
Who said it over here? 8. But we have a cup and then a half a cup. So how many is in a half a cup? 4. So if I have 8 and 4, how many do I have together? 12. 12 fluid ounces. Now we need to figure out how many fluid ounces can we get out of 30 fluid ounces? How many cups can we get? So what are we going to do? We're going from fluid ounces. Here we go. What are we doing? We're going to divide. 30 divided by 12. You can do the division, but some of you guys, I'm hesitant for you to do that because you're going to get a decimal, and I guess you can convert. You're just adding extra steps. Here it is. 30 over 12. Rewrite that. 2 and 1/2. Some of you might have gotten 2 and 6/12. That simplifies to 2 and 1/2 anyway. Yes? Yes, go ahead. I'll show you visually. I have 30 blocks here, and I don't need the singing, so knock it off. I have 30 blocks here. If I count by 12s, that's 12. Here's another 12, I'm up to 24. But then I only have 6 to get me to 30. So that's 1, 2, and then this is half of 12, 6 out of 12. So 2 1/2. If I'm counting by 12s, 2 1/2 counting by 12s gives me to 30. Okay, but that's really just dividing. And remember, fractions is the same as division. So I rewrote that as a mixed number. So now, this is the easy one. This is what I need you to do. 1 cup servings, how many are there in 50 fluid ounces? Rewrite that. That should take you maybe 2 minutes, tops. Come on, try. Try this. If you have questions, you're going to have to go back to that a little bit later. I got to get through these examples. How am I going to solve this? Who could walk us through that? A day.
Okay, so since 1 cup equals 8 fluid ounces,
So look at what we did up here with the 30 and the 12. Nice. Okay, go ahead.
50 divided by 8.
Nice. And then we can rewrite that instead of 50 divided by 8, make it a fraction, and then just shift into mixed number mode.
Yes, so.
There it is.
Yes.
Quinn. So the setup is right today. Good. Now I need to forward because we're running out of time. Look, we have these two bikes. We need to get the lightest bike because we got a big competition. You're a pro cyclist. First place, $10,000. Second place, $5,000. Third place, $2,000. You see the same set of pros at the competitions that you always do. You're always in the top 3. It's time for you to get a new bike. Your bike's getting old. You've been competing with this bike for too long. You want the lightest bike possible. So which bike am I going to get? I want the lightest bike. I didn't say the cheapest bike or the most expensive bike. There's 2 ways to do this. I can either convert ounces to pounds or pounds to ounces, but what I want you to do is convert pounds to ounces. How many ounces are in a pound?
16.
So what am I going to do?
16.
Multiply or divide?
Divide.
I'm going to multiply.
Oh.
So I take my mixed number and I multiply it, but I can't multiply until I do what to my mixed number?
Convert it into a per.
So once I convert it, now I can multiply. Now, you could have cross-canceled and you could have avoided this. Okay, I'll let you guys deal with that. You end up with 68 over 1, which is how much that bike weighs. This one weighs 68 ounces. Which one's the lighter bike? The Super Cycle. Now, listen. This one right here, it tells you specifically to go from ounces to pounds. What am I going to do? Multiply by what? Nice. Here's the answers. So I have 16 times 37 over 8. I don't know why I hear the talking. 74 ounces. Last slide. Now, this is what it said earlier. From gallons to quart, am I going from large to small or small to large? Gallons not smaller than quarts. So in order to convert, stop talking now. We're going to multiply. Thanks. Pints, actually, ounces to pounds. Is that small to large or large to small? So is it going to be multiply or divide? Is that small to large or large to small? Shh. Just answer my questions and stop arguing. So what am I doing, multiplying and dividing? Is this large to small or small to large? Sit down today. So what am I doing? Is this large to small or small to large? So what am I doing? Nice, divide. Is this large to small or small to large? So what am I doing? Okay, now, why do you multiply to change from a larger unit to a smaller unit? Can somebody share with me what that is? Nathan, go ahead.
Because the more miles and feet than 1 mile, there's like
Okay, so here, you guys are, this is what you guys tend to do. You're very wordy. I don't know why I'm talking and people are talking over me. You try to write and hope somewhere in your writing there's the answer. It's a very concise answer. It takes more smaller units to each equal 1 larger unit. Think about it. 16, think about it. How many inches in a foot? There's 12 of them, right? That's the smaller unit. So here's the flip side. Why do you divide to change from a smaller unit to a larger unit? No, think it's opposite this.
It takes larger units to equal to the smaller.
Thank you, Nathan. There are fewer larger units to equal the smaller units. Okay, now, questions. Who had the questions? What are the questions? I have no questions now? You guys forgot your questions? You don't want to ask any questions? Okay, well, I went through the problems. You guys, this homework is due on Tuesday. This is lesson 9. The quiz on Monday is up to lesson 8, and lesson 8 homework is due.